Question. Okay, so this question is from the light portion. A student investigate reflection in a plane mirror. A ray trace sheet is shown. So this is the ray trace sheet. What you have to do. Okay, what is the trick in it? You have to read the lines one by one, and you have to do it there. Okay, so I'm going to number them. This is, let's suppose, the one. Draw a normal to the line MR that passed through the center of MR. Label that as NL. Okay, so I have to first find the center. If I see this thing is, let me place 0 on one corner, this is 10 centimeter. So there is its center. Okay, so I have found the center. I have to draw a normal on it. So normal will be like 90 degree. You can see clearly on the scale. I'm going to choose 90 degree. Okay, so you have to draw the normal. You can draw a dotted line. Okay, like this. Call this N. Sorry, you have to call this thing NL. This is N and this side is L, let's suppose. Second point is label the point NL crosses MR with the point B. Now this is the point where it is crossing it, you have to label it B. Now third point, draw a line 10 centimeter from B at an angle of incidence 40 degree to the normal MR below MR. Okay, the line should be below MR and left of the normal. So if it is below MR, it should be in this region, and left it's mean it should be in this region. So you have to draw the line there below and on the left. So and its angle should be 40 degree. Okay, so 40 degree angle to the normal. Okay, they have instructed it very clearly. So let me do it from there. What this angle is, this is 90. You can take the angle with the protector. I'm doing this with a scale here. So you have to take 90 and I have to take 40 degrees. So 90 minus 40 is 50. So it's on this digital measuring device. I can draw it like this. Okay, I guess they have, this is the 40 degree. I guess they have given the length of the line as well. This is, yes, it should be 10 centimeter. Okay, so you have to be very careful about all the instructions. So I'm going to place 0 on one side. Where is the 0? Okay, I have placed a 0 on the one side. It's okay, I have to extend it a bit. There it is. Now it is 10. Okay. Okay, and what we have to name it, label the end of this line as A. Okay, this end is A. Perfect. So moving forward, part B, this is for the 2 marks. The student places the reflected face of the mirror vertically on the line MR. He places 2 pins P1 and P2 on the line AB. Mark the position of P1 and P2 with crosses on line AB at the suitable distance. What is the suitable distance? It should be more than 5 centimeter. This is the criteria you have to keep in mind. For this type of ray trace experiment, label the position. Okay, so they should be 5 centimeters apart. So we don't need the scale here. I'm marking 1 point here, 1 point here. Okay, it does not matter. I know the full length is 10 centimeters, so I'm taking more than half of the length distance apart. So you can name this as P1, you can name this as P2. It should be more than 5 centimeter separation of P1 and P2. Okay, so we are done with the B thing. B, that's for the 1 mark. Moving forward to the C, what they are asking in C, the student views the image of P1, P2 from the direction indicated by the eye. He places 2 pins P3 and P4 so that the pins P3 and P4 images P2 and P1 all appear exactly one behind the other. The position are shown. Achha, what they have given you the scenario that they have placed a mirror here. You can, this is some mirror, okay. You don't have to draw it, just to give you a context. They have placed a mirror here. Okay, so what you have to do now, this is the thing that we have to do. Draw a line through the position P3 and P4. Continue the line until it meet MR. Okay, so continue the line until it meets MR. Okay, P3 and P4. The P3 and P4 are already mentioned. You just have to draw a line. They haven't told us how long it should be, so you can draw it of any length. I'm doing it like this. Okay, so there you go. I guess they haven't told, okay, they haven't told us that how much long it should be, so you can draw it anyway. The second part, this one we are doing, measure the acute angle alpha between this line and the horizontal MR, and acute angle is the angle less than 90. Okay, between, measure the acute angle between this line and the MR. This line is, they're talking about this line, and this is the MR. You have to measure this angle. Okay, so let's measure it. You can use the protractor. I'm, this is 0, and when I bend this thing, or this is 1. Okay, okay, it's 131 or 132 almost. Okay, so this thing is basically, on this digital scale that I'm using, this thing is showing 180, and this is showing 132. So 180 minus 132, it's giving me 48 degrees. Okay, so this angle is 48 degree as per our drawing. Okay, so this is called as alpha. If this is 48 degree, this thing will be 42 degree. That is almost equals to this thing. Okay, we will discuss this thing in the next part. In D part, this is 48 degree that I have got. Okay, the units are already there. Okay, the student turns the mirror through 180. He draws a new incident ray at an angle of incidence 50 degree to the normal above MR and left of the normal. Okay, so you have to do this thing now. First, I'm going to do this thing, then we will discuss this. Okay, so let's try to do this. The student turns the mirror 180, draw an incident ray at the left, on the left side, on this side, and on the top. So this is the way. There you have to, with the 50-degree angle to the normal. If this is, let me use my digital scale, this thing is 90 on the scale. So if I have to move 50 degree, I have to go there. It should give me 90 plus 50, it should give me 140. Okay, so this is 50-degree angle from here. You have to draw a line. Okay, so this is 50 degree. You can measure with the protractor. They have called it I. Okay, and now let's move to the next instructions. This one we are going to try. He labeled the end of the line C. The line is not shown on figure 3.1. You may draw the line on the figure. Okay, this point you have to call C. Okay, and then again, next part, he places two pins on the CB and view the image of the two pins from near top right hand corner of the ray trace sheet. On figure 3.1, draw a reflected ray 10 centimeter long from B with an angle of incidence beta equals to angle of incidence. Label the end as D. Okay, so what you have to do now, you have to draw the angle, the reflected ray. If this is 90, normal is 90, I am moving there, it should be, okay, so this is Okay, this should be for 10 centimeter, they have told us. So this point is 0, this is this, and there you go. Okay, it should be straight line. Okay, so this is incident ray, this is reflected, and this is angle beta. This is also 50 degree. Okay, and you have to call this and as D that they have told us. Okay, so we are done with this part as well. This is for the 2 marks. Okay, so in the light ray tracing question, you just have to follow the instructions step by step. This is the key. That's it, and you can do the question very easily. If you try to do it all at once, if you try to read it and draw it all at once, there is a high probability you will do the mistake. In part E, suggest a relationship between alpha and beta. Justify your answer by reference to the result. So what they are equal. Okay, why they are equal? Now you should be thinking. One was, if you remember, let me show you. Where is alpha? Alpha is 42 and beta is 50. So they are nearly equal. So you can write they are in limit of experimental accuracy. Okay, how you know what is the limit of experimental accuracy? You can say, okay, this is just for your knowledge, that if readings are in range of 10% plus minus 10%, they considered equal. Okay, so if you see, if you take value of 40, 10% of 40 is 4. So what is the range of the 40? 40 plus 4 is 44, and 40 minus 4 is 36. So any value between these 36 and 44 can be considered equals to this thing. Okay, so that is how you have to answer this question in ATP. State two techniques that you use in this type of experiment to obtain an accurate ray trace. Okay, what you are doing in this, you are placing the pins, you are drawing the rays, and okay, so what you can do, the pins you are placing, they should be thin. You can write down the lines should be sharp. You can say draw, let me use the other pen, draw sharp lines. Okay, and or you can say the pins should be far apart, at least 5 centimeter. Okay, or you can say place the pins exactly vertically. Okay, it's your choice, you can write down any.